Okay, in Chapter 2, we're going to focus on the addition, subtraction, multiplication, and division of fractions. First of all, a fraction is an indicated quotient that represents a portion of the whole thing. Fractions are written in the form of one number over another number. For example, a proper fraction will look something like this, with one number over another number, and the top number is considered to be a numerator, and the bottom number is considered to be a denominator. Here's some other examples of proper fractions, like 2/3, 9/10, and 24/25. Again, the top number is considered to be the numerator, and the bottom number is considered to be the denominator. Okay, an improper fraction looks something like this. It appears where the numerator is greater than or equal to the denominator. For example, you may have 8/5, 3/2, 10/9, or 25/25, which is technically the same as 1. Any number over another number is always considered to be 1. So those are identification fractions that identify with improper fractions. And then finally we have mixed numbers. And a mixed number has a whole number, such as the whole number 1 and 3/5. 1 plus a portion of another, and it's 3/5 of another. For example, I could have a pie right here, and the pie is divided up into 4 equal slices, and the blue right here represents the portion of the pie that has been eaten. So there's 4 parts, so 3/4 of the pie has been eaten, which means that 1/4 of the pie has not been eaten. So you have a mixed number right here where it's 1 and 3/5. So you have 1 whole pie plus 3/5 of another pie, and in this pie there's 5 slices rather than 4 slices. Other examples of mixed numbers would be like 1 1/2. So 1 whole pie plus half of another pie would have been eaten. And then 1 1/9. Or you could have the whole number of 1 to be considered a mixed number. Okay, we're going to move forward and take a look at some ways to do conversion of improper fractions to mixed numbers. We have to look at the conversion principles first and foremost. Okay, see if I can scoot that up any higher. There we go. So to convert an improper fraction to a mixed number, let's do that first. Okay, let's take the 17/5. Okay, that's a value, a fraction that I really can't interpret. I don't know what it means, especially since the numerator is larger than the denominator. So one of the things I can do is to convert it to something that's meaningful to me, the reader of this fraction. I have to be able to communicate what this actually means. So I want to divide the denominator into the numerator. So that'd be 5 into 17. 5 will go into 17 3 times. 3 times 5 is 15, and it leaves a remainder of 2. So the remainder will become my numerator, and my denominator will be the divisor of 5. So 3 2/5 is really what this improper fraction of 17/5 means. If you want to put it in the perspective of a pie, it could mean 3 whole pies plus 2/5 of another pie, the fourth pie. Let's convert. Now, let's go backwards and convert a mixed number to an improper fraction. And we'll have to do this quite a bit whenever we're doing multiplication and division of fractions. Okay, so let's take that same value, 3 2/5 that we converted earlier in part A, and let's convert that to an improper fraction. All you have to do is take the denominator 5 and multiply it times the whole number. So that would be, okay, so 5 times 3 is equal to 15 plus the numerator of 2 equals 17 over the like denominator of 5. 17 over 5 is how you convert the mixed number 3 2/5 to the improper fraction 17 over 5. Okay, now if you were to reduce fractions to lowest terms, let's say that we have the value, the fraction that's 10/15. To reduce that fraction to lowest terms, we can use what is referred to as the step approach or the step method. That's whenever you divide your numerator into your denominator. So in other words, I'm going to take the numerator of 10 and divide it into 15. And 10 will go into 15 one time. 10 times 1 is 10 with a remainder of 5. I take my remainder and I divide it into the previous divisor of 10. 5 will go into 10 two times. 2 times 5 is 10 with no remainder. So therefore, the last divisor used is 5. So 5 will go into 10 two times, and then 5 will go into 15 3 times. So 2/3 is your final answer to reduce it down to lowest terms. You may have to take up quite a bit of space when you're working on this type of a method, but it really does help you break down a fraction into its lowest terms more quickly. This is only a 2-step process on this one, but it can be 30, 40 steps depending on what kind of fraction you're working with. Okay, let's go ahead and take a look at some prime numbers. Prime numbers is a number that is divisible by 1, is only divisible by itself and 1, and it's called a prime number. The most common prime number, or prime numbers, is 2, 3, 5, 7, 11, and I'll keep going a little bit, 13, 17, 19, 23, 29, 31, 37, 41, and 43, and on and on and on. For this particular course, all we'll have to really focus on are 2, 3, 5, 7, 11. Those are the ones we'll focus on. How can you memorize that? Just remember 2, 3, 5 and get a Slurpee at 7, 11. 2, 3, 5, get a Slurpee at 7, 11. Okay, we're going to add these numbers right here. We're going to add 1/3, 1/6, 1/8, 1/12, and 1/9. Okay, typically whenever you add something, by the way, you have like denominators. You just bring the denominator across and then add the numerators. For example, typically whenever you add, let me find a different color and I'll give you an example of this. If you have 2/5 plus 1/5, that will equal 5 is your like denominator, so you just bring it across and then add your numerators. 2 plus 1 is 3, so your answer is 3/5. That's a typical way of how you add fractions. Okay, whenever you don't have like denominators, you have to come up with the common denominator of 3, 6, 8, 12, and 9. And we can use a prime number approach to come up with one. Now, whenever you're looking at 3 and 6 and 8 and 12 and 9, you may be able to use the observation method and say, you know what, I think that 72 is probably the lowest common denominator that's common to each one of those numbers, and you would be correct. But not everybody can do that quite so easily. So we can use the prime number approach to help us determine what the lowest common denominator would be. Well, the way I do it is I start with the lowest prime number, which is 2, and then I divide that into each one of the possible denominators of 3, 6, 8, 12, and 9. Okay, I look to see if the lowest prime number will go into any of those. So 2 will go into 6 3 times, 2 will go into 8 4 times, 2 will go into 12 6 times, and 2 won't go into 9 or 3. So I just bring those numbers up. I'll change that back to red to show you that I just bring these up. Okay, now I'm going to go back to that same color again, and then I look at the next step, and I go, well, 2 go into any of those, and it will. 2 will go into 4 2 times. 2 will go into 6 3 times, but 2 will not go into 3 or 9, so I'm just going to bring those numbers up. Okay, I go back into it, look to see if 2 will go into anything again, and it will go into itself one time, and it won't go into anything else. So I just bring the other values up to the next higher level. And I look at it again. Will 2 go into any of those? No. So I go to the next prime number, which is 3. Okay, 3 will go into itself one time, and then 3 will go into 9 3 times. But it will not go into 1, so I will bring it up. Okay, now look at it. Will 3 go into any of those? Yes, it will go into itself one time, but it won't go into 1. So I just bring those numbers up. And whenever you get to the top row of all ones, you're finished. Then all you do is multiply your divisors. 3 times 3 is 9, times 2 is 18, times 2 is 36, times 2 is 72. So 72 is my common denominator. So I multiplied those, and it equals 72 for the lowest common denominator. Okay, so now I'm going to change all my fractions over here to 72. And I'm going to convert all of these fractions to higher terms. Okay, 3 will go into 72 24 times, so 24 times 1 is 24. Okay, 6 will go into 72 12 times. 12 times 1 is 12. 8 will go into 72 9 times. 9 times 1 is 9. 12 will go into 72 6 times. 6 times 1 is 6. And then 9 will go into 72 8 times. 8 times 1 is 8. Now I'm ready to add the numerators, which comes to 59 over 72. So that's my final answer, is my fraction for this diverse problem of addition is 59 over 72. Okay, now we're going to add mixed numbers. When you're adding mixed numbers, first you're going to add the whole number. Second, you're going to add the fractions. And remember that the keep the denominators common. And then 3, we're going to combine the two totals. Making sure no improper fraction exists in final answer. Okay, so add mixed numbers, add the whole number, add the fractions, and then keep the denominators common whenever you do that, and then combine the two totals, making sure that no improper fraction exists in the final answer. Okay, I want to take the problem of 3 6/10, 10 3/5, and 6 3/4. Okay, I can see that I have denominators that are not common, and so I basically have to find a common denominator. Whenever I look at that, I go 10. Okay, 10 will go into itself. 5 will go into 10. Oh, 4 won't go into 10. Sometimes when you multiply a couple, you go, okay, 5 times 4 is 20. So 5 will go into 20. 4 will go into 20. And 10 will go into 20. So I bet you 20 is your lowest common denominator, and you would be correct in making that assumption. But if you can't see that initially, well, just use the prime number approach that we used on the previous screen. I would use the all of the common denominators of 10, 5, and 4. And I'd start with the lowest prime number, which is 2. Remember, it's 2, 3, 5, 7, 11. Start with 2. 2 will go into 10 5 times. 2 will go into 4 2 times, but it won't go into 5, so I'm just going to bring 5 up. Okay, 2 will go into itself 1 time, but it won't go into 5, so I'll just bring those up. 2 will no longer go into any of those, so I go to the next prime number, which is 3. 3 will not go into any of those, so I go to the next one, 2, 3, 5. So 5 will go into itself 1 time. It won't go into 1, so I bring it up. Once you get to a top row of just ones, you're done, and then you multiply your divisors. So that's 5 times 2 is 10, and then 10 times 2 is equal to 20. So 20 is the lowest common denominator. So now I'm going to bring 20 over here. And convert those fractions to higher terms. 10 will go into 22 times. 2 times 6 is 12. Okay, 5 will go into 24 times. 4 times 3 is 12. And then 4 will go into 25 times. 5 times 3 is 15. So now I add up the numerators, and I come up with 24, 34, 39. 39 over 20, which is an improper fraction. We don't want to leave it that way. And then whenever I add up the whole numbers, 16, 19, comes up to 19 and 39 over 20. So I've got to convert this improper fraction to a whole number. And whenever I do that, I'm going to divide the bottom number into the top number, the denominator into the numerator, and it will go one time with a remainder of 19 over 20. So to do that, I'm going to mark that out and add 1 and 19/20, and then that will equal 20 and 19/20. 20 and 19/20 is your final answer. This concludes adding the mixed numbers. Okay, now we're going to take a look at subtraction. Okay, subtraction. Okay. Typically, whenever you subtract, for example, 7 nines, and you subtract from that 3 ninths, you have a like denominator. It stays the same, and then you subtract 3 from 7, which is 4. So 4 ninths is your final answer. Okay, if you have something to this degree, where it's 7 ninths minus 2 sevenths, you realize immediately that you have to have a common denominator, and again, you can use the prime number approach. For example, if you have 7 and 9, you can start with the lowest prime number of 2. Then 2 doesn't work, so go next to the next prime number, which is 3. 3 will go into 9 3 times. 3 won't go into 7, so just bring it up. 3 will go into itself 1 time, but it won't go into 7, so just bring it up. And then 3 won't go into either 7 or 1, so I go to 2, 3, 5. Now I'm ready for 5. 5 won't go into either 1, actually, so I'm going to mark that one off. 2, 3, 5, 7. So 7's the next one. 7 will go into itself 1 time. It won't go into 1, so I'll just bring it up. I have a top row full of 1s, so I'm done. So now I'm going to multiply the divisors. So 7 times 3 is 21. 21 times 3 is 63. So 63 is going to be my common denominator. And 7 will go into 63 9 times, and 9 times 2 is 18. 9 will go into 63 7 times, and 7 times 7 is 49. So now I can subtract 18 from 49, which is 31, and then use the like denominator of 63, and the answer is 31 over 63. Okay, now I'm going to go ahead and add another component to this. We're going to subtract, and this one's going to create a little bit of a problem, this next portion. Let's say that we take 15 and 5/8. We're going to subtract from 15 and 5/8, we're going to subtract 3 and 7/8. Oh, yay, we have a like denominator. So I'm going to put 8, but uh-oh, got a problem. I cannot subtract 7 from 5. If that happens, I'm going to have to borrow from this 15 and then add 8/8, which is equal to 1. If I subtract from the left side, I'm going to add it back to the right side. Okay, so I'm going to scratch this out. Let's try this again. Since we realize it won't work, going to go ahead and try it one more time. 15 and 5/8 minus 3 and 7/8. And I can't subtract 7 from 5, so I am going to borrow from the whole number, which makes 15 14, and then add a whole number, and I'm going to use 8 because that's what the denominator, the like denominator is. I'm going to use 8 over 8, and that's going to equal 13 over 8 minus, and then use the 7/8 that's here, and then now I can subtract 7 from 13, which is 6 over the like denominator of 8, and then 3 from 14 is 11. So I have 11 and 6/8, and I realize immediately that I can reduce 6/8 down to lower terms. So I can take 2 into 6 3 times, and 2 into 8 4 times, which equals 11 and 3/4. Okay, let's try this one more time. If I have 29 and 1/6, and I'm going to subtract from that 5 and 2/3. Okay, my big problem right here is that I don't have like denominators, but I could use the observation method, by the way. And I realize that 6 will go into itself and 3 will go into 6 twice. So I'm good by using the observation method. But again, if I can't see that, I can use the step approach to determine what is the last divisor that's used that will go into both the numerator and the denominator evenly without a remainder. So the first thing I'm going to do is come up with a like denominator, which is 6. 3 will go into 6 2 times. 2 times 2 is 4. 6 will go into itself 1 time. 1 times 1 is 1. I cannot subtract 4 from 1, so I must borrow from the whole number to make it 28, and add the whole number back to the right side, which is 6 over 6, since that's the like denominator, and that will equal 7 over 6, and then subtract from that 4 over 6. Okay, 4 from 7 is 3 over the like denominator of 6, and then subtract 5 from 28, which is 23. Then 3 will go into itself 1 time, and then 3 will go into 6 2 times. So that's equal to 23 and a half. Okay, now let's multiply proper fractions. And whenever you're multiplying, first we are going to multiply the numerators. Then multiply denominators. Okay, secondly, we're going to reduce to lowest terms. Okay, so if we have 5/8 times 2/3, we don't have to worry about like denominators in multiplication and division. So 5 times 2 is 10, and 8 times 3 is 24. And then I can use the step approach to determine what number will go in both the numerator and denominator evenly without a remainder. Or I could use the observation method, and I could say, you know what, I bet 2 will go into 10 5 times, and 2 will go into 24 12 times. So my final answer is 5/12. Okay, so let's try this one and use cancellation on the same problem. Again, 5/8 times 2/3. And anytime that you use a cancellation method, you can see what goes into a numerator, and then if it has a matching denominator, that will go into evenly as well. It can be to the side or it can be immediately below it, but never cancel going horizontally, only vertically. So therefore, in this particular problem, I know that 2 will go into itself 1 time, and then 2 will go into 8 4 times. Okay, I am done. That equals 5 times 1, which is 5, and 4 times 3, which is 12. 5/12. Using cancellation method, where I don't have to reduce it down to lowest terms, because I finally made it to lowest terms. Okay, let's go in and multiply mixed numbers. When you multiply mixed numbers, a key component is to change the mixed number to an improper fraction. Then multiply. Okay, so if you have 1 1/3 times 2 2/3 times 5/8. First, convert the mixed numbers to improper fractions. So 3 times 1 is 3 plus 1 is 4, which is 4/3, times 2 times 3 is 6 times 2 is, 3 times 2 is 6 plus 2 is 8, so that's 8/3, times 5/8. Okay. Now I can use the cancellation method, and whenever I look at this one, I can see that 8 will go into itself 1 time, and 8 will go into itself again 1 time. That looks like the only thing that I can break it down to. So now I'm going to cross multiply. 4 times 1 is 4, times 5 is 20. 3 times 3 is 9, times 1 is 9. So it's 20/9. And then all I have to do is divide the denominator into the numerator. 9 will go into 20 2 times. 9 times 2 is 18 with a remainder of 2. So the answer is 2 2/9. Okay, now dividing proper fractions. Okay, first, invert the reciprocal or divisor. Boy, I can't read my writing. And multiply. What is the reciprocal or the divisor? It's the second fraction in a series. Okay, so if we have 1/2 divided by 3 3/4. First thing we're going to do is take 1/2 and we're going to invert the reciprocal, the second in a series, which is 3/4. We're going to change that to 4/3. And then multiply 1/2 times 4/3. Okay. So 2 will go into itself one time, 2 will go into 4 2 times. So 2 times 1 is 2, 3 times 1 is 3. So your answer is 2/3. Okay, now we're going to divide mixed numbers. First, change all mixed numbers to improper fractions. Then follow steps in dividing proper fractions. Okay, for example, you have 1/2, and you're going to divide that by 1 5/8. Okay, convert the mixed numbers to an improper fraction. So 2 times 1 is 2, plus 1 is 3/2. And divide that by the improper fraction. 8 times 1 is 8, plus 5 is 13/8. And then invert the reciprocal. So that would be 3/2. Change the divide sign to a multiplication sign. And then 8/13. Inverting the reciprocal or the second fraction in the series. Okay, now I can go ahead and use the cancellation method. And 2 will go into itself 1 time. 2 will go into 8 4 times. Okay, 4 times 3 is equal to 12. And then 13 times 1 is equal to 13. Therefore, the answer to this division problem is 12/13. Okay, to summarize, not really a summary, but just to kind of put something into perspective a little bit, let's draw a ruler and divide this ruler into tenths. So I'm going to start with a ruler, and I'm going to start with 0, and I want to put a tick here, 1, and that'll be, since we're dividing it into tenths, I'm going to make this 1/10, 2 for 2/10, 3 for 3/10, 4 for 4/10, halfway through at 5/10, 6 at 6/10, 7 at 7/10, 8 at 8/10, 9 for 9/10, and then finally 10 for 10/10. Then I'm going to reduce down to lowest terms. 2/10 will break down to 1/5. 4/10 will break down to 2/5. And 5/10 will be 1/2. 6/10 will be 3/5. And 8/10 will be 4/5. And 10/10 will be 5/5 or 1. There's your 1 inch. So whenever you're looking at this from a perspective, you can look at this from the perspective that technically 1/2 is greater than 2/5. It's larger than 2/5. Or you can look at it from the perspective that 7/10 is larger than 3/5. Or 4/5 is larger than 7/10. This kind of puts it into perspective whenever you're looking at the fractions that have unlike denominators. This concludes Chapter 2.